Hi, my name is Isabel Mendiola. I am a teacher from Mexico. For 15 years, I have been teaching physics, chemistry, and biology. I'm the writer of the Arduino Classroom STEAM Edition.
Hi, my name is Peter Haydock. I am a former curriculum developer for Smithsonian and National Geographic. I've also been a classroom teacher. I'm here from Wisconsin, and I am Isabel's co-author on the Arduino Classroom STEAM Edition. We are very excited to be the facilitators for the teen conference this year for the Wisconsin Association for Talented and Gifted 2020 virtual conference. We're sad that we can't meet all of you in person, but we are excited to be sharing the work from our curriculum via the virtual format.
In this workshop, you are going to be learning how to develop prototypes such as this one, which is servo motion using dimmers or potentiometers.
We're going to be practicing the skills of digital prototyping, engineering design, coding in C++.
Why don't we show the participants what we are going to build?
Excellent. What we have here are the parts and pieces for this prototype. The first part is the most important, which is the microcontroller. Think of this as a little computer. We're going to upload the code into it, and the code will be transmitted along these wires along with power to run the entire project. We have the wires. We have this white part. This is called a breadboard. It allows the electricity and code to get to the right places. We have 2 potentiometers, and we have 2 servos. Now, when you upload the code and you hook all of the wires up correctly, you can then control the servos with the potentiometers. These are really like dimmer switches that you might find on the wall in your house to control the lights, make them brighter or softer. So with this potentiometer, we can control this servo. With this potentiometer, we control the other servo. Okay. The code allows us to determine the speed of the servos and how quickly they turn. It also controls the range of motion. In our case, we've programmed these to code for 0 to 180 degrees. So some of that math and geometry that you were talking about. But we could code it for 0 to 90 or 45 to 135. We have a lot of options here that we can build.
Yeah, some of the projects that we have is Baby, which is a cardboard robot. We use this prototype as an example. And we have as well a robotic arm in which we are using 4 servos. And in this case, we are using Bluetooth.
So what you learn here is the foundation for many other projects going forward. And someday when you wrap all of this together, you could be a NASA engineer developing the next robotic arm for, say, the International Space Station or for the next Mars rover that goes out. And while we were preparing for this video, we found some excellent clips showing engineers using other kinds of robotic arms.
In this workshop, we are going to be guiding you using our curriculum, the pages of our book, and to finish the process here.
Now, you will receive a box like this in the mail from us. This box actually includes all of the materials to build the first 6 projects in the book. Now, this workshop, we're only doing project 6, the last one, but there's other pieces in there. Yeah. You want to show our participants what else they're going to be getting?
So this is the kit we are going to be working with. So let's take a look what is inside. In here you will find the list of components, and let's take a look to the right side of this kit. We have the USB cable, which is the connection to our computer and the microcontroller. We're going to be using an Arduino Uno. Then we have the breadboard, which is the connections wires and the microcontroller. So in here we have wires that we're going to be using, and the 2 servos, and those servos are going to be controlled by potentiometers. There are other parts that we can be using or we can use for other projects, which is LEDs of different colors. And these LEDs are going to be connected to 220 ohms resistors. As well, we have for music or sound a piezo or buzzer. And then if we want to disconnect the project from our computer, we can use a 9-volt battery connected to a barrel. So basically this is what the kit has.
It's very exciting to us to be in this conference because we want to share with you the experiences that we have had in the classroom with our students, how they have learned and how they have applied this information in their lives.
Well, we're very excited to be presenting the team conference this year. We look forward to meeting all of you virtually. Hopefully someday we can meet in person. If you have any questions, please reach out to WATG and we'll be more than happy to answer questions about the workshop. But in the meantime, we look forward to preparing for the conference. Look forward to meeting you and seeing you in October.
Yes.
Thank you.
Thank you.